Good morning, class. So today we're looking at the June exam of 2020. The reason why this is a bit shorter and we only have one paper was because of this was the COVID era. No? That time we all were at home with the lockdown. Now grade 12 wrote shorter exams. Okay. Alright, so here we are told that the graph below shows the men's 15-meter freestyle world record progression from John T. Skinner, which is 23.86 seconds, South Africa's record in 1976, and then Peter Williams, and here you can see all those reading there, and then the Brazilian of 2019. 2009, sorry. Let me close this a bit, make it a bit smaller. Right, so here we are now, we look at this data here, what do you see? We see that as x increases, the y is decreasing, or as the years increases, the time in seconds decreases. Okay, can you see that, people? People, is this a perfect correlation? Is this a relation perfect? Is it very close to perfect? Can I draw a line going through most of these ones here? No. Not so? But it's clear what is happening. Not so? There's no outliers, there's no extreme values, really, and so on. Alright? I think that will come a bit down because concentration on these dots here at the bottom. So that's basically what your least squeeze regression line should look like. Okay. Let's go to the first question. Oh, the first question says draw. Okay. Draw the line of best fit and predict the value of the correlation coefficient. So now, remember that scale I gave you. That was 0. 1 was perfect. Minus 1 was also perfect. Not so. Then you got 0,5, which was moderate, which is average, and negative 0,5. But this is probably between, it is not very, very strong. No? It is strong because it's lying around this line of best fit here. Can you see that, people? So I would say, if they ask you to predict the correlation coefficient, I would say your odd value is anything between negative 0,8 and negative 0,6 or 7 there. Okay, anything between that would have been a reliable solution, or a reliable odd value. Why negative? Because it's coming down, it's decreasing. Can you see that, people? What was the answer in the memo? Somebody must just follow the memo first. Same. The full question and question paper and memo can be found in the description box below. So in number 1.2, we are told that the line of best fit is given as negative 0,0673x plus 156,23. Predict the new world record at the next year's 2021 World Swimming Championship. Okay, that dot mustn't be here. Give a reason for your answer correct to 2 decimal places. Okay, so of course not every year is there a new record. Can you see that, people? Not so? But if it is the next record for the year 2021. So if you look here, it will simply be y is equal to negative 0,0673x plus 156,23. 2021. 2021. And you see that is correct. So it's negative, or is it just the years on? Okay, I will check now. So 0,673 multiplied by 2021 plus 156, 20 seconds and 22 split seconds. Yeah, that's about it. That's it. Is that correct, people? So it's going to be 20 comma 2 seconds. That will be the next world record according to the line of perspective. Then we said, will your prediction in question 1.2 be an interpolation or an extrapolation? Now what's an interpolation? An interpolation means to say it's a value that is lying between this data set here. Can you see that, people? Where the minimum value of years is 95, 67, 97, 1977 or 1976, sorry, and this one here comes in at 2009. Can you see that, people? So if it's anything outside this, it's called that extrapolation. Can you see that's on the outside? Is it fair to go and say and predict what's happening in the year 2020? No. Why? So it's an extrapolation. Why? Because there's no data values covered in here. You guys understand? So the answer here is going to be an extrapolation. Also comment on the reliability of your prediction. Is it reliable? No. Why? Because that's outside the data set. Okay, anything within the data set is going to be a reliable calculation. Okay. Well, question 2. Question 2, we're given the sketch. The given sketch represents, okay, there's the sketch, represents triangle ABD with vertices A, B, which is 8 and 1, and D. The equation of AD, okay, the equation of AD is negative 2x plus y equals negative 5. C, which is 6 and 2, is the midpoint of AB. Then we are told that D is vertically above C. So if D is vertically above C, what do we know already of D? We know the x value. Not so. But it's now, of course, vertically above. Just put this off here. Okay, so the x value of, what's your x value here? 6. And some y value. Okay. Let's go to the first question. As you can see, it's very important to read through that information. So the first question says, determine the coordinates of A. Determine the coordinates of A. So as you can see here, A is the endpoint. So let's make A x and y. So x1, which is x, plus x2, which is 8 over 2, is going to give us 6. Y1, which is y, plus y2, which is 1 over 2, is going to give you an answer of 2. So what we do, we put this over 1 and we cross multiply. So we get x plus 8 equals 12. X is equal to 4. So the x value of A is 4. It's gone this side. Over 1 we cross multiply. So y plus 1 is equal to 4. So y is equal to 3. As you can see, that makes sense on the diagram that we have there. 2.2, the question says determine the coordinates of D. So we know that D is 6 and a y value. Not so? We will substitute that into negative 2x plus y equals negative 5. That's a x and a y. So you got negative 2 times 6 plus y is equal to negative 5. That's negative 12. Take negative 12 over, becomes positive 12, so y gives you an answer of 7. So therefore D is 6 and 7. So any confusion there? Very simple, huh? Let's go here. Then we are told that write down the equation of DC. So what do we know about DC? It's parallel to your y-axis. So what's your equation of the DC? Is x is equal to 6. That's simple. 2.4. Show that DAB, this angle is 90 degrees. So how do we prove something is 90? The product of the two gradients must be -1. Okay. So the gradient of, so this is the 2.4 now. So we work out the gradient of AB. So it's going to be y2 minus y1 over x2 minus x1. Okay? So you will have 3 minus 1 over 4 minus 8. It's going to be safer for me actually to use these 2 points. Reason being, that was given just in case I made a mistake here, then you won't see that the product of the two will be -1. You guys understand? So let's go. That's going to give us 2 over -4, which is negative r. Now I know that we're working out the gradient of, for the gradient of AD. I'm going to make so that
apologies for the interruption. Lawyer Mangalise Zozi, can you please make your way to Ms. Van Heerden's classroom immediately? Lawyer Mangalise Zozi, to report to Ms. Van Heerden's classroom promptly.
So I'm very upset. It sounds like she don't want to be there. None of you is that person, yeah? Right, so we must get it firstly in the standard form. Why? So that we can extract what m is, the gradient. Okay. So we got y is equal to, we take that over the equal sign, it becomes 2x minus 5. So what's the gradient of AD? 2. So we say the gradient of AB times the gradient of AD equals half in the negative times 2, which is -1. Since that is the case, therefore BAD is equal to 90 degrees, or you can say it's perpendicular. Okay. See any confusion there? Right, let's carry on. People, question 3. In the diagram, the circle with center C. Okay, the diagram. Right, nice. We're told that in the diagram, circle with center C, and with equation x squared minus 6x plus y squared minus 4y equals 12.
My apologies for the
intersect the y-axis.
We need the following learners to report to the office immediately.
BA
Sumila Gamani
is a tangent to the circle.
Octavia,
So that means to say
Yasha,
that's going
and
to
Blessing
be.
Norikafi. Those learners, if you can please make your way to the office immediately.
You all agree that would be 90 because it's a tangent to the circle. Okay.
Also,
B lies.
Mrs. Patel's grade 11s, can you please make your way to her classroom? Mrs. Patel's grade 11s, can you please report to her classroom?
Grade 11 seem to be naughty this year, no? Yo, nothing like you people were. Right, but anyway, so B lies on the x-axis with the angle of, with B, AY is equal to alpha. Right, so the games begin. Right, first question. It says calculate the coordinates of C. OCT here. The coordinates of C, people. So we must get it in the standard form of a circle. Is the circle at the origin, the center of the origin? No. So what do we say? It must be in the form of x minus a squared plus y minus b squared is equal to r squared. So let's go. We got x squared minus 6x plus a number, complete the square root, plus y squared minus 4y plus a number is equal to 12 plus the first number plus the second number. And how do we get this number? It's going to be b times half, which is 6 times half is 3 and 3 squared is 9. 4 times half squared is 2 and 4 times half is 2 and 2 squared is 4. So this now can be written as x minus 3 squared plus y minus 2 squared is equal to 30 plus 12 is 25. What's the coordinates of C? 3 and 2. What's the length of the radius? It wasn't asked. 5. And remember, this is r squared. Okay? That's your r squared value. You all okay with that? The next question says calculate the coordinates of A. So what is A, people? A is your y-intercept. Can you see that? How do you calculate y-intercept? So y-intercept, we let x equal 0. So I'm going to go with this here. I could have gone with that, no problem. So I say 0 minus 3 squared plus y minus 2 squared is equal to 25. 25 minus 9 is 16. So y minus 2 squared is equal to 16. How do I get rid of the square? Square root. If I introduce square root, plus minus. So y minus 2 is equal to plus minus 4. So y is equal to 2 plus minus 4. So y is equal to 2 plus 4, which is 6. Or y is equal to 2 minus 4, which is negative 2. Which one of the two is A? And why is it 2? 2 values for y. So there are 2 points where the circle cuts the y-axis. Namely at negative 2 and at 6. So therefore A will have an answer 0 and x is 0, y is 6. Any confusion there? No? Let's look at the next question. Here we are told the equation of tangent AB. So what do we know about the tangent and the radius? They stand perpendicular to each other. Of course, with the tangent, I need 2 points on the graph. Oh, I need the angle. Not so? However, for the radius, we know that the gradient of AC, which is your radius, is equal to changing y by changing x. That is 0 and 6. So it's going to be 6 minus 2 over 0 minus 3. 6 minus 2 is 4 over negative 3. So what's the gradient of the tangent? Remember that the gradient of the tangent times the gradient of the radius is negative 1. So the gradient of the tangent is 3 over 4. So we got y is equal to 3 over 4x plus c. But c is normally a y-intercept. What's the y-intercept of this tangent? 6. There we go. Okay. Let's go with the next question. The size of alpha, round your answer off to 1 decimal place. Size of alpha, round your answer off to 1 decimal place. But if you look at this here, if I got this angle there, then I can go with angles on a straight line. Not so. Or I can work out this angle here, which shouldn't be a problem. So I got the gradient of this line. We know that the size of this angle is 90 because that's perpendicular. The x-axis and y-axis is perpendicular. So the exterior angle is equal to the sum of the two interior angles. Can you see that? Let's call this theta for now. So we know that tan of theta is equal to the gradient of AB, which is 3 over 4. That is AB, no? That was your tangent. So arc tan of 3 over 4 Arctan of 3 over 4. Whoops. Arctan 3 over 4. View 36 comma 8 7. So therefore alpha is going to be 36 comma 87 plus 90 degrees. Why? Because this is exterior angle of triangles equal to the sum of the two interior opposite. That gives you 126.87 degrees. Okay, is that correct? Okay. Is there any confusion there? Number 4. Oh, it's just way too big. In the diagram represents circles with equations. You've got x plus 3 squared plus y minus 3 squared is equal to 1. And one possibility of circle B with center B at 3 and 5 and radius R. Okay, so let's make this capital R. Okay. First question. So this equation belongs to that circle, no? How that looks so. The first question reads, write down the coordinates of A. Simple. What's the coordinates of A? Should it be minus 3A? You all agree with that? Why? Because it's the additive inverse of that and that. Okay? Number 2 question says, determine whether A, B, and C are... People, what does collinear mean? Lies in the same line. Not so? So let's check. To check if some is collinear, you check if the gradients are equal. So you work out the gradient of AC. So the gradient of AC, C of course is negative 1 and 4. So it's going to be 4 minus 3 over negative 1 minus plus 3. Which gives you 1 over 2. So if the gradient of AB or the gradient of BC is also half, the job is done. Not so. So the gradient of AB is going to be 5 minus 3 over 3 minus minus 3, which is 2 over 6, which is a third. So are the points A, B, and C collinear? No. Is that the right coordinate? Therefore, A, B, and C are non-collinear points. Okay. You guys understand? Okay. .3. In question 4.3 we are told, calculate all possible lengths of R for which the circle A and B will never intersect nor touch. Calculate all possible lengths of R for which the circles of A and B will never intersect or touch. Leave your answer rounded off to 2 decimal places. People, firstly, R can never be negative. No? The radius of this circle here, the radius of this circle is 1. Okay, so if we take this circle into account, let's see what's happening here. It's about the same size, it makes sense for us. Okay, so that's basically what we have, no? A circle. So if there's a variable on R, that means to say that thing can get bigger, not so. So you can get bigger with that being the center B. Bigger, 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 bigger. Until it's going to get so big that it's going to intersect. Not so. At some point, of course, it will intersect. With that being the center. So that's one scenario. It must be less than that. Or it must be more than that. Because if that's now the center, you see it's going to touch there again. So if the circle could touch there, it wouldn't conform to what the question is. Can you see that? And you can go, 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 go until it's going to not intersect on this side again. Can you see that, people? So there's actually two scenarios here. Okay, so let's try. Calculate all possible lengths of R for which the circles A and B. Okay, so in other words, let's work out the length of AB. Okay, so that's going to be the square root of let's see. So it'll be negative 3 minus 3 squared plus. I might be going on the wrong point of view. Let me just see something quickly before I waste unnecessary time. The squared plus 3 minus 8 squared. Maybe root 61. It might fit in some. Okay?
3 minus 5.
Sorry?
3 minus 5.
3 minus 5. 2 root 10. Okay, okay. Okay, so that is the state here from there to there. Okay, so we know that the distance, which is 1 plus R, must definitely be a length. If it's equal to this, that means to say that will intersect. Can you see that, people? It has to be a value less than 2 root 10. That's in the first case. Okay? So R1 must be a value less than 2 root 10 minus 1. Okay? And then on the other hand, if you're going to go where the circle is actually touching, that's the center touching here. There. Okay? This would have to say that R2 plus how do we do it in the memo?
So on the right hand, just after that, when they
So this is right like it is, that one, and this is right.
yes.
Okay.
And then adjust R is greater than 0 but less than 2.
Oh yeah, yeah, no?
Yes.
Right, greater than 0. Remember I said this had to be positive. No? Okay, and what else am I losing out of? And this one is still right.
No, sir. We leave that out. That's the final answer.
Okay, yes, I think that is confusing me here. Because the question says calculate all possible length for arc which the two circles will never intersect or touch. So what the initial question, when I set it up, I consider that to be touching. That's within the circle. Can you see that? So I can only consider the first scenario where the circle is going to touch this point here. Remember when I draw the circle? It's the scenario only where that will touch that is a concern. Okay. Alright. Sorry about that, got a bit confused there. 4.4. The question says the line, first take this off here. So now we are told the line y is equal to x plus 8 touches the circle B at D. Okay, so that is a straight line graph touching the circle at y is equal to 8, x plus 8. So that is going to look something like that. Okay, so y is equal to x plus 8. It could cut twice. Okay, they didn't tell us the tangent or a secant as yet. If it's a tangent, it will look like that, one top there somewhere. If it's a secant, it's anywhere between that. Okay, let's carry on reading. The line y is equal to x plus 8 is a tangent. Sorry, so it will touch once. So you can touch, it's either going to look like that or like that. No? One of the two. I think it's more that one. Because of the 8. Yeah, definitely that one. Because of this 8. As you can see, it's going to cut to y-intercept at 8. So it's going to be higher there actually. But anyway, the line y is equal to x plus 8 is a tangent to the circle B at D. So there's going to be a D on top. So D is going to be P and Q. Okay? Calculate the value or the values of P and Q if the radius of circle B, the radius of circle B is 3 root 2. Okay. Okay, so firstly we know that the radius is perpendicular to the tangent. We all agree with that. Okay, what must we calculate? That point of contact P and Q. Okay. So what I'll do is I'll probably complete the triangle here. Okay, so it will look something like this. I'll give you a rough sketch here. Will make more sense. Remember this point here, where that's going to cut your x-axis is going to be at negative 8. Of course, that is 8. This is your D, which is P and Q. That is your is 90. That's 3 root 2. And D. That's what we have. A right angle triangle. So with that, we can actually calculate this length here of that line. Let's call this M and that N. Okay, so let's call this M and N. So I'm going to take this diagram away. Alright. So for M, it's going to be the distance formula. So it's going to be the distance. It's going to give you, now this is 3 and 5, so it's going to be, so it's going to be 3 minus 8 squared plus 5 minus 0 squared. So that gives you an answer of the square root of 11 squared plus, what's that? 5 minus 8, so it's 3 squared, which is 9. So it's root 130. Okay, so that's 130 here. So to calculate N, for N, I'm going to apply Pythagoras. So N squared is equal to the square root of 130 squared minus 130 squared minus 3 root 2 squared. Alright, so that's your Pythagorean theorem. There's going to be answer squared minus 3 root 2 squared. $120, $112. The square root thereof is 4 root 7. Is that correct? So n is going to be 4 root 7. Why did I calculate this? So that I can see, you see there's two unknowns here. Okay? So what I'm going to do is I'm going to work out the distance formula in terms of P and Q. Okay? But that's also unnecessary. Why? Because I have already 3 root 2 here. Sorry, man. I didn't actually need this. Because what I was going to do is I'm going to now work out my distance formula in terms of P and Q and minus 8 and 0. But why did I need that? Because I already have this here. Okay, so I'm going to move this up. I didn't need to do this. Because it's not necessary now. Sorry about that. So we can say that 3 root 2 is also equal to, remember that's the distance of the radius, and I'm going to now write that in terms of P and Q. So it's going to be P minus 3 squared plus Q minus 5 squared. Okay, so I'm just going to get rid of the square root, so I'll square both sides. So it's going to be 9 times 2, which is 18. So 18 is equal to P minus 3 squared plus Q minus 5 squared. And that's equation 1. Now to get another equation, we know that this P and Q is lying on the straight line. Can you see that? So what we're going to do is we're going to substitute D, which is P and Q, into y is equal to x plus 8. Why do I do that? To generate another equation in terms of P and Q. There's the x and the y. So Q is equal to P plus 8, and that's equation 2. So what do I do now? I substitute wherever I see Q, P plus 8. So what do we have now? We have therefore 18 is equal to P minus 3 squared plus P plus 8 minus 5 squared. So I'm going to get rid of the brackets, so it's going to be 18 is equal to P squared minus 6P plus 9. This of course is going to give you P plus 3. Okay, so that's going to be plus P squared plus 6P plus 9. And of course the P's are gone. 9 plus 9 is 18. Sorry? That's what I'm seeing now here. So P is 0. Is that correct?
Yes, sir.
Okay, so that means to say it's on the y-axis. That's basically what it means. Okay, so P is equal to 0 then. And then how do we calculate the Q value? We sub that back into equation 2. So therefore Q is equal to 0 plus 8, which is 8. Therefore D is 0 and 8. Okay. People, these answers should always make sense to you. Okay, that's why I paused there a bit, just to see where that 0 is going to lie. Okay, that's a nice part of analytical geometry. No? And Euclidean. It should always make sense for the diagram that is given. Okay, so which means to say if I make this bigger, then this point here, the circle will be cutting the y-axis, and that point where the tangent cuts the circle is actually on this axis here. So on the y-intercept. Okay? Yeah, beautiful question. Yes? Sorry, is it wrong? Where were you for yesterday's lesson? Sorry? You had to go home? How much we feel? We stayed there till 6 o'clock waiting for you. Alright. People, question 5. Right, we are told that A Right, we are told that ABD is a triangle in the horizontal. Should be the triangle in the horizontal plane. So, okay, so you assume that's the ground. DC is a pole, so the pole will be perpendicular, of course, to the ground, perpendicular to plane, to this plane. Then we are told that AD is equal to BD. The angle of elevation from A to C is alpha, and ADB is 2 alpha. The question says, prove that for 8 marks. Question says, prove that. Prove this here. Let's prove that the AD is equal to, that's stored AD. Okay. If we look at what is needed to be proved, what do we have? H is the H. So I have to use both triangles. Okay. So if we're going to work with a simpler triangle, which is ABC, what can we say? So there's A, which is alpha, B, C, and this is now of course H. We must use which length? The length between the two triangles, and CD. Which trigonometric function? You see it's a 90 degrees. Uses opposite and adjacent. Tan. So we say tan of alpha is equal to opposite, which is H, over adjacent, which is AB. Cross multiply. So we've got AB tan of alpha is equal to H. So AB is equal to H over tan alpha. Okay. Now in the other triangle, the triangle looking like this now. So that is twice alpha. That is the A1, B1. So because I have so many lengths here, I'm going to use a sine. Okay. However, I can calculate the lengths of, or the angles, the size of A1 and B1. We know that A1 and B1 is the same. Okay, and that is of course 180 minus 2 alpha divided by 2. Why? Because we're using two theorems here. Sum of triangles and as well as angles opposite equal sides. Now, we don't have to give that recently. Why? Because we're not busy with Euclidean geometry. So that's going to simply be 90 minus alpha. Okay, 90 minus alpha. Alright, so there's 90 minus alpha, and that's 90 minus alpha. So what I'm going to say is sine of twice alpha over AB, or AB over sine 2 alpha is the same thing, equals. Now I need to calculate, or I must make AD the subject of the formula. So it will be AD over sine 90 minus alpha. Okay, I'm going to make AD the subject of the formula, so I'm going to take it up. So therefore AD is equal to AB sine. Now 90 minus alpha, you become cos in your first quadrant. It's positive cos alpha over. Now sine 2 alpha can be written as 2 sine alpha cos alpha. So what's going to happen now? causes cancer. Can you see that? So in other words, AD is going to be AB over 2 sine alpha. You all agree with that? But that is still not what they asked us to prove. Not so much. I'm just going to put it here. Can you see that? That's not what they asked us to prove. Okay? So what we now do is we say, okay, AB can be replaced with, or should be replaced with, h over tan of alpha. Can you see that? So that is simply, therefore, AD is equal to h over tan of alpha, which is AB, and must be divided by 2 sine alpha. This can be written like that, or we're going to say h over tan of alpha over 2 cos alpha. But we know it's part of the domain. Okay. People, what can tan be written as? Sine over cos. So it's going to give you h over sine alpha over cos alpha times 2. Yeah, times 2 sine alpha. Not so. Now, this is over 1. So at the bottom we will have h over 2 sine squared alpha divided by cos alpha. But what does this mean? 2 divide. So it's h divided by 2 sine squared alpha over cos alpha, which is the same as h times cos alpha over 2 sine squared alpha. And that's the same as what we needed to prove. Alright? People, you guys understand? Any confusion there? So we got question 5, 6. There's a lot of questions left. So we'll conclude this question, what's the name? In our next lesson. People, enjoy the long weekend. Are you asking for another paper? What's the name? Yes. Okay. And I know you guys know. The question paper and memo can be found in the description box below.